Alchemy and chemistry in Islam refers to the study of both traditional alchemy and early practical chemistry, the early chemical investigation of nature in general, by scholars in the medieval Islamic world. The word alchemy was derived from the Arabic word kimya or kimi, and may ultimately derive from the ancient Egyptian word chemi, meaning black. After the fall of the Western Roman Empire, the focus of alchemical development moved to the Caliphate and the Islamic civilization. Much more is known about Islamic alchemy as it was better documented. Most of the earlier writings that have come down through the years were preserved as Arabic translations. Topic: Definition and relationship with medieval Western sciences. In considering Islamic sciences as a distinct, local practice, it is important to define words such as Arabic, Islamic, alchemy, and chemistry, in order to gain a better grasp on the concepts discussed in this article. It is important to come to an understanding of what these terms mean historically. This may also help to clear up any misconceptions regarding the possible differences between alchemy and early chemistry in the context of medieval times. As A.I. Sabra writes in his article entitled, "Situating Arabic Science, Location versus Essence." The term Arabic or Islamic science denotes the scientific activities of individuals who lived in a region that roughly extended chronologically from the 8th century AD to the beginning of the modern era, and geographically from the Iberian Peninsula and North Africa to the Indus Valley and from southern Arabia to the Caspian Sea, that is, the region covered for most of that period by what we call Islamic civilization, and in which the results of the activities referred to were for the most part expressed in the Arabic language. This definition of Arabic science provides a sense that there are many distinguishing factors to contrast with science of the Western Hemisphere regarding physical location, culture, and language, though there are also several similarities in the goals pursued by scientists of the Middle Ages, and in the origins of thinking from which both were derived. Lawrence Principe describes the relationship between alchemy and chemistry in his article entitled, "Alchemy Restored", in which he states, "The search for metallic transmutation, what we call alchemy, but that is more accurately termed chrysopia, was ordinarily viewed in the late 17th century as synonymous with or as a subset of chemistry." He therefore proposes that the early spelling of chemistry as chemistry refers to a unified science including both alchemy and early chemistry. Principe goes on to argue that their chemical activities were unified by a common focus on the analysis, synthesis, transformation, and production of material substances. Therefore, there is not a defined contrast between the two fields until the early 18th century. Though Principe's discussion is centered on the Western practice of alchemy and chemistry, this argument is supported in the context of Islamic science as well when considering the similarity in methodology and Aristotelian inspirations, as noted in other sections of this article. This distinction between alchemy and early chemistry is one that lies predominantly in semantics, though with an understanding of previous uses of the words, we can better understand the historical lack of distinct connotations regarding the terms despite their altered connotations in modern contexts. The transmission of these sciences throughout the Eastern and Western hemispheres is also important to understand when distinguishing the sciences of both regions. The beginnings of cultural, religious, and scientific diffusion of information between the Western and Eastern societies began with the successful conquests of Alexander the Great 334–323 BC. By establishing territory throughout the East, Alexander the Great allowed greater communication between the two hemispheres that would continue throughout history. 1,000 years later, those Asian territories conquered by Alexander the Great, such as Iraq and Iran, became a center of religious movements with a focus on Christianity, Manichaeism, and Zoroastrianism, which all involve sacred texts as a basis, thus encouraging literacy, scholarship, and the spread of ideas. Aristotelian logic was soon included in the curriculum. A center for higher education in Nisibis, located east of the Persian border, and was used to enhance the philosophical discussion of theology taking place at the time. The Quran, the holy book of Islam, became an important source of theology, morality, law, and cosmology, in what Lindbergh describes as the centerpiece of Islamic education. After the death of Muhammad in 632, Islam was extended throughout the Arabian Peninsula, Byzantium, Persia, Syria, Egypt, and Israel by means of military conquest, solidifying the region as a predominantly Muslim one. While the expansion of the Islamic Empire was an important factor in diminishing political barriers between such areas, there was still a wide range of religions, beliefs, and philosophies that could move freely and be translated throughout the regions. This development made way for contributions to be made on behalf of the East towards the Western conception of sciences such as alchemy. While this transmission of information and practices allowed for the further development of the field, and though both were inspired by Aristotelian logic and Hellenic philosophies, as well as by mystical aspects, it is also important to note that cultural and religious boundaries remained. The mystical and religious elements discussed previously in the article distinguished Islamic alchemy from that of its Western counterpart, given that the West had predominantly Christian ideals on which to base their beliefs and results, while the Islamic tradition differed greatly. While the motives differed in some ways, as did the calculations, the practice and development of alchemy and chemistry was similar given the contemporaneous nature of the fields and the ability with which scientists could transmit their beliefs. Contributions of Islamic alchemists to mystical alchemy. Marie-Louise von Franz describes in her introduction to Ibn Umayl's Book of the Explanation of the Symbols, Kitab al-Rumuz, the contributions of Islamic alchemy as follows. In the 7th to 8th century, Islamic scholars were mainly concerned with translating ancient Hermetic Gnostic texts without changing them. Gradually they began confronting their content with the Islamic religion, and began to think independently and experiment themselves in the realm of alchemy. Thus they added an emphasis on the monotheistic outlook, Tawhid, and more creating a synopsis of the diverse antique traditions. Thus unifying their meaning, the Islamic scholars arrived at the idea, that the secret and aim of alchemy were the achievement of one inner psychic experience, namely the God image, and that stone, water, prima materia etc. were all aspects of the inner mystery through which the alchemist unites with the transcendent God. Secondly, they added a passionate feeling tone, by using much more a poetic language than the antique Hermetists did, also giving a greater emphasis on the conjunctio motif, i.e. images of the union of male and female, sun and moon, king and queen etc. The mystical masters of Islam understood alchemy as a transformative process of the alchemist's psyche. The fire which promoted this transformation was the love of God. Alchemists and works. Khalid ibn Yazid. According to the bibliographer Ibn al-Nadim, the first Muslim alchemist was Khalid ibn Yazid, who is said to have studied alchemy under the Christian Marianos of Alexandria. The historicity of this story is not clear. According to M. Ullman, it is a legend. According to Ibn al-Nadim and Haji Khalifa, he is the author of the alchemical works Kitab al-Kharazat, the Book of Pearls, Kitab al-Sahifa al-Kabir, the Big Book of the Roll, Kitab al-Sahifa al-Sakhir, the Small Book of the Roll, Kitab wasiyatihi ila bienihi fi sana, the Book of his testament to his son about the craft, and Firdaus al-Hikmah, the Paradise of Wisdom. But again, these works may be pseudepigraphical. Jabir ibn Hayyan. Jabir ibn Hayyan, Persian, Jabrian Arabic, Jabir Hayyan Latin Geberus, usually rendered in English as Geber, may have been born in 721 or 722, in Persian city of Tus, Iran, and have been the son of Hayyan, a druggist from the tribe of Al-Azd who originally lived in Kufa. When young Jabir studied in Arabia under Harbi al-Himyari. Later, he lived in Kufa, and eventually became a court alchemist for Harun al-Rashid, in Baghdad. Jabir was friendly with the Barmecides and became caught up in their disgrace in 803. As a result, he returned to Kufa. According to some sources, he died in Tus in 815. A large corpus of works is ascribed to Jabir, so large that it's difficult to believe he wrote them all himself. According to the theory of Paul Krauss, many of these works should be ascribed to later Ismaili authors. It includes the following groups of works: the 112 books, the 70 books, the 10 books of rectifications, and the books of the balances. This article will not distinguish between Jabir and the authors of works attributed to him. Abu Bakr al-Razi. Abu Bakr ibn Zakaria al-Razi, Latin, Razes, born around 864 in Rayy, was mainly known as a Persian physician. He wrote a number of alchemical works, including the Sir al-Azrar, Latin, Secretum Secretorum, English, Secret of Secrets. Ibn Umayl. Muhammad ibn Umayl al-Tamimi was a 10th-century alchemist of the symbolic mystical branch. One of his surviving works is Kitab al-Waraqi wa al-Ard al-Najmiya, the book on silvery water and starry earth. This work is a commentary on his poem, the Risalat al-Shams ila al-Hilal, the Epistle of the Sun to the Crescent Moon, and contains numerous quotations from ancient authors. Ibn Umayl had important influence on medieval Western Latin alchemy, where his work is found under different names, mainly as Senia or as Zadeth. His silvery water, e.g., was reprinted as the Chemical Tables of Senia Zadeth in the collection of alchemical texts, Theatrum Chemicum, and commented upon by Pseudo Aquinas in Aurora Consurgens. They both also give his modified image of the sage holding a chemical table, see image above. Al-Tagra'i. Al-Tagra'i was an 11th–12th century Persian physician, whose work Themasabi al-Hikmah wa Mafati al-Rahmah, The Lanterns of Wisdom and the Keys of Mercy, is one of the earliest works of material sciences. Al-Jildaki. Al-Jildaki, who was a Persian alchemist, urged in his book the need for experimental chemistry and mentioned many experiments Kanz al-Iqtisas fi Marifat al-Khawas by Abu al-Qasim Idamir al-Jildaki. Alchemical and chemical theory. Jabir analyzed each Aristotelian element in terms of Aristotle's four basic qualities of hotness, coldness, dryness, and moistness. For example, fire is a substance that is hot and dry, as shown in the table. According to Jabir, in each metal two of these qualities were interior and two were exterior. For example, lead was externally cold and dry but internally hot and moist. Gold, on the other hand, was externally hot and moist but internally cold and dry. He believed that metals were formed in the earth by fusion of sulfur, giving the hot and dry qualities, with mercury, giving the cold and moist. These elements, mercury and sulfur, should be thought of as not the ordinary elements but ideal, hypothetical substances. Which metal is formed depends on the purity of the mercury and sulfur and the proportion in which they come together. The later alchemist al-Razi followed Jabir's mercury-sulfur theory, but added a third, salty, component. Thus, Jabir theorized, by rearranging the qualities of one metal, a different metal would result. By this reasoning, the search for the philosopher's stone was introduced to Western alchemy. Jabir developed an elaborate numerology whereby the root letters of a substance's name in Arabic, when treated with various transformations, held correspondences to the element's physical properties. Processes and equipment. Al-Razi mentions the following chemical processes: distillation, calcination, solution, evaporation, crystallization, sublimation, filtration, amalgamation, and ceration, a process for making solids pasty or fusible. Some of these operations, calcination, solution, filtration, crystallization, sublimation and distillation, are also known to have been practiced by pre-Islamic Alexandrian alchemists. In his Secretum Secretorum, al-Razi mentions the following equipment: tools for melting substances, li tadwib, hearth, kur, bellows, minfak or ziqq, crucible, bortaka, the but in Arabic, from Persian, or botus barbatus in Latin, ladle, mirafa or milaka, tongs, masik or kalbaton, scissors, mikta, hammer, mukasir, file, mibrad. Tools for the preparation of drugs, li tadbir al-akaka, cucurbit and still with evacuation tube, qar or anbik dukat m, receiving matras, kabila, blind still, without evacuation tube, al-anbik al-amar, aladel, al-uthal, goblets, kada, flasks, karura, plural kawara, rosewater flasks, ma, wardia, cauldron, marjal or tangier, earthenware pots varnished on the inside with their lids, kidir and makabat, water bath or sand bath, qidr, oven, al-tana in Arabic, athana in Latin, small cylindrical oven for heating aladel, mustorkid, funnels, sieves, filters, etc. See also: Chinese alchemy, Islamic science.